Hello again. Today I'm gonna start a series that'll take you through making guitar pickups yourself. There are plenty of kits going around from Mojo Tone, Stu Mac, and I'm gonna show you how to make them. I used to run my own pickup company before I got a job that I couldn't turn down, and so I'm going to take you through how to make it, both using a DIY winder and a professional winder. I think we're going to make a humbucker, but we might do single coils as well. Single coils are so simple that if you can make a humbucker, you can make a single coil as well. It's a lot easier, and I'm going to take you through the process, at least show you the differences between single coils and humbuckers. But now for the first video, we're going to talk about wiring, which is an important step to making guitar pickups and making your guitar sound good if you want to make it yourself. So we're going to start with single coil wiring. Now this is just a single coil cover. Single coil is single coil. It's a very simple electromagnetic tool to get your guitar string sound amplified. And some get confused when it comes to guitar wiring, which you don't have to, because it's as simple as electronics can get, basically. Maybe that's why people have problems with it, because it's maybe too simple. So first of all, we're going to talk about the pot. I'm just going to use this as an example pot. Let's say this is one, and this is 10. On, for example, a Strat, where you would have numbers, or you'd have numbers on all of them, basically. Now, this is your point of reference. Be it your pick guard or whatever. And as you dial it up, what the pot is doing is increasing the resistance between the signal and the ground. Basically, if your ground and your signal are short-circuited, there will be no sound. Which is what a kill switch does. It short circuits the signal from the pickups to ground, basically letting no signal out, grounding all the signal, and it will be silent. Now what the pot does, as you turn it up, it increases the resistance to ground, be it volume or tone. If you have it on 10, depending on your pot, you'll have maximum resistance to ground for that pot. If your pot is 250 Ks or 1 meg, the maximum of that pot would be the resistance between ground and signal. So what does that mean? Well, it means for volume, what you're basically doing is you're short-circuiting the two lugs on the pot that are connected together, meaning that there will be no resistance between in on the pot and out on the pot, but there will be resistance to ground. So your volume pot meter doesn't really really make a difference. But it's just basically normal to just use the same pot for volume as you do on your tone. Now for tone, they're wired in a different way. And I'll show you later, in such a way that the amount of resistance affects the tone. It goes through a capacitor, and the amount of signal going through that capacitor to ground affects your sound. Meaning, the higher resistance your pot has, the brighter your tone will get. The less impact that capacitor will have on your tone. Having it turn all the way up to the max, it's the max resistance between that capacitor and your signal. Now, a capacitor will dull down your signal. A capacitor will take down your trebles, high mids, depending on what capacitor you're using. So we're going to start by drawing up a simple standard single coil guitar wiring diagram. Okay, so this is a roughly drawn out blank. I had to hand draw this. I don't have any templates and I'm not a graphic designer. I usually just hand draw these on papers like this, stick them to the wall and wire the guitar by that. So I'm going to use different colors for the pickups to make it easy. My camera is in front of me, meaning this is upside down to you, but I've written the volume and tone controls so that you can read it. Probably wouldn't be a problem anyway, but you know, I just did. Now ground is gonna be black. Ground on the guitar, it's your shielding, all your hardware, your sleeve cap. Let me see, this sleeve on your guitar jack. The tip is hot. The sleeve is ground. So this is going to give the ground connection to the entire guitar. Now bear that in mind as we start drawing up the ground first. So the ground will be the ring part of the jack. This is the jack connector. It will be the ring part, the one that the metal part that touches around the sleeve of the jack. Now this is ground. The symbol for ground is this, but I'm going to draw everything up so you don't have to think about this symbol, but just bear that in mind. When it comes to how you ground, some schematics or wiring diagrams will have this symbol by the pickups. This doesn't mean that you have to have shielding. In fact, you shouldn't connect ground to the shielding in more than one place. What that means is you draw your ground connectors down to one of the grounded pots. But I'm going to draw everything out very quickly, very simple. This is the pickup selector switch. This is a five-way connector. This sometimes confuses people, but just note that these lugs, the soldering lugs, are offset. So try to use that as some way of orientating yourself. Also bear in mind that they work differently. They work opposite of what you'd, well, not what you'd expect, but it works opposite from what you'd think, meaning that you turn the switch down towards the jack on the guitar. It's the connectors that are up towards the pickups that are active, and vice versa. It's round, but this is seen from the back side of the guitar, or inside the pick guard or whatever. So we're going to draw up the ground first, and I'll get back to you. Now, realize I forgot the soldering lugs for the pots, but that's up now. The first thing you'll want to do is connect the ground connection on the jack to the lug on the volume. Now this also has to be soldered to the cap of the volume pot, and this is just to have we'll use this as a general grounding area for the entire guitar. Now since we're using the tone control, this tone control, to have the capacitor connected, to avoid having to go all the way over here with the capacitor, we're grounding this as well. So we'll just take a wire, solder it to the cap there, and that's basically the ground connections done for this. We'll also use one ground connector for each of these, down to the pot, down to the pot, and down to the pot. Now if you have a tremolo or whatever kind of bridge you have, let's just draw up a quick tremolo here. I'm trying to draw this upside down. Trem arm on it. It has to be grounded as well. Usually it's grounded through the screws in the fulcrum point. There's some kind of wire or film down there. The manufacturers alter this, or it's on the springs on the underside. Your springs are on the back side of the guitar, and the ground connection is there, squeezed between the screw and the spring holder. This also, take it down, get it to this pot here. That's that. That's done. Now there's no more proper ground connections, although these two are connected by ground, not through the caps of the pots or the enclosure of the pots, but through the lugs. And it's these two legs. So that's next. If you're doing guitar wiring, I'd screenshot this and yeah. And but now we'll move on to the neck. I'm trying to draw an N upside down. I'm not a genius, but I think I can pull that off. Now you want this to go through the pickup selector, because you don't want it to cause interference down here if you're not using it. So we use red for the neck, and since it's, if the neck, you know, you're pulling it up towards yourself, so the lever would go that way, meaning that this is the lug we'll want to go to. Okay, so what you actually might end up doing is connecting this the other way around. What you want to do then is just shift everything one step, if that's what you'll end up doing. Okay, now the middle pickup. The middle pickup will go one step above that, it's not rocket science, this. It's, you know, if you have it like that, you're in the now you're in the neck position, middle position, bridge position of the lever, if you can imagine that. So basically the bridge position pickup will go to that lug. Now these wires will be longer, of course, and we want to keep them tight. I'm just trying to draw this out for you. So I'm gonna switch to a different color again. Let's try gray. I don't know if you can see gray. Yeah, you can see that. Because there are some, you have to connect different pieces together to get this to work. You want the overall volume, independent of which pickup is selected, you'll want that to go down to the volume pot. Otherwise, you'll have to have different pots for each pickup, and you don't want that. So we're going to, and that's this lug and this lug. So you'll want these two connected together. So you'll often see they're placed in the middle, like so, on a guitar, depending on how big the switch is. But usually, if you buy high quality switches, they're usually substantially, they're massive. They're very well made hardware. No, that won't work. Let's see. Let's try orange. There we go. Gray looks like black on the camera. So you'll want these two connected together, and from one of these lugs, it doesn't matter which one, go down to the volume pot. Okay. Now, as you can see, there's only one left on the volume pot. Now, where does that go? Well, you need sound to come out of the guitar, right? So it has to go to the tip of your jack connector. Now this is the tip, the part of the jack connector that, well, makes a sound. You know, if you touch it, it's the hot one. Now, as you can imagine, there will be wires coming out of these as well. This will basically be send and return for the tone stack. I call it tone stack. I don't know what it's really called. I'm not natively speaking English. I'm Norwegian, so we have our own names for certain things. But I'd call it tone stack now. I'm going to use orange for that as well, because it's not that hard. It's not that difficult to understand. But what we do need is a capacitor, and that can take many shapes and forms. It can be square, have lugs like that, and it can be little and round, orange one with long, thin legs. But we're just going to use this one now for the diagram. Now you'll want to solder this directly, one of the legs directly to the enclosure of the pot. So this will go here, the other one will go to this lug. And you want to keep this as short as possible. So usually you'll just have a 1/4 of an inch maybe on each side, and just have it standing on the side of the cap of the enclosure. Now this is the capacitor. Can I draw a C upside down? Yes, I can. And this capacitor will affect both of these pots, since this is also connected to ground via this lug. So basically both of these are going through the capacitor and to ground. So as I said, this is the send going out, and we're we're basically just gonna take it right down to the middle lug and return from this middle lug to this lug. I don't know if you can see that. Maybe I can try and color this in a bit. And that's basically the tone stack of the guitar. It's okay, so that's basically it. The single coiled guitar wiring diagram. Now you can find better diagrams than this online, obviously, computer drawn. I just wanted to take you down down the path of drawing it up, because it's might be easier for somebody to take it step by step. And this is the first video of my pickup making videos. I'll have one coming out each week, I hope. I'm quite busy at the moment, so I can't just go out into my workshop and make a pickup just like that anymore. And also the recording and editing time is substantial for me. I'm not a computer wizard. I wish I was. I'd be able to do this a lot faster. Now, just want to talk about screening very very quickly. You may notice that some guitars have a copper film inside the body, especially with single coil guitars, and that is to omit any well, we call it radiation in Norwegian, but it's basically interference. It's noise coming out. You may sometimes hear that your guitar starts humming in a different way whenever you turn on a light or is near a TV or things like that, and screening may alter that. Now, what you want to bear in mind is for a ferritic chamber, which the screening is, you will need to have the back side of your pickguard screened as well. Usually they are. Some cheaper manufacturers do not do that. But if they come in copper or a tin foil or aluminum foil, doesn't really matter. But what you want to make sure of is that it's only grounded in one place. Just solder a tiny bit of cable to that, a wire, and solder it to your pot. You do not want many soldering points or ground connections to that screen, because you could create an antenna using that. If you connect here and here, and by some chance or something happens, there might be potential voltage potential between these two. You will basically have an antenna going between those 2 points. You don't want that. You want one ground connection to avoid ground loops and antennas. So that's it. I'll be back with more videos in a while. I might do, I think I'll do a humbucker wiring diagram before I start making the humbucker. I think I will make the humbucker first. There's more parts and yeah, little tips, hints and tips, and do's and don'ts when it comes to making your own humbucker. So, see ya.